Hi students, welcome to all of you to this concepts and snippets session. Today we are going to discuss the P block elements. In the modern periodic table, elements are classified into 4 blocks based on their electronic configuration. Elements of S block, most electropositive elements, whereas elements of P block are less electropositive elements. In fact, it is a block which contains metals, non-metals and metalloids. Remember, P block is the only block which has all the 3 types of elements. Now let us discuss what are P block elements. You have to study P block in +1 as well as in +2. That means this block has such a wide variety of elements with unique properties. In +1, we discuss group 13 and group 14 elements. Boron family, elements of group 13, and carbon family, elements of group 14. Okay, so let us start our discussion of P block elements and boron family. In +1, we focus on boron family and carbon family. Okay, so elements in which the P subshell, elements in which the P subshell of the outermost shell, P subshell of the outermost shell is gradually filled up, are called P block elements. Okay, their electronic configuration is outermost shell is N, where the S subshell has 2 electrons, while the P subshell is progressively filled. As you know, P subshell has a maximum capacity of 6 electrons. Therefore, there are 6 groups of P block. So, P block elements belong to group 13 to group 18 except helium. Even though helium is included along with group 18, it is an S block elements. Okay, so this is the introduction to P block. The electronic configuration, the definition. Now let us look at boron family. In boron family, group 13 elements, boron family, okay, boron, a typical non-metal, followed by aluminium, a typical metal, boron, aluminium, gallium, indium, thallium, and the newly discovered element of group 13, it is called nihonium. Please remember it. Nihonium is the newly discovered element which is artificially made and it is radioactive, NH. Okay. Now, as you move down the group, the non-metallic character increases, non-metallic character decreases, while the metallic character increases. Okay. Clear, no? Thus, boron is the typical non-metal. Boron is a typical non-metal, while other elements are metals. Clear, no? Now, what is the group oxidation state? As you move down the group, the tendency to show an oxidation state with the 2 units less than the group oxidation state is observed. It is because of a property called inert pair effect. I repeat, in P block, as you move down the group, the tendency to show a lower oxidation state 2 units less than the group oxidation state is observed. It is due to inert pair effect. Inert pair effect is due to poor shielding effect of inner D and F electrons. Clear? Thus, boron shows a stable oxidation state of 3+, aluminium shows +3, Gallium also shows plus 3 in its compound. Indium has a tendency to plus 1 and plus 3, while the stable oxidation state of thallium is plus 1. This is the stable state. It is due to a property called inert pair effect, which we are going to discuss in detail. Clear? Now, let us discuss a simple question. Write the composition of borax. It is a mineral of boron. It is a mineral of boron and it has wide applications in glass manufacturing industry. Heat resistant glass. They are called Pyrex glass, which are made up of, which contain boron trioxide. So borax is added to heat resistant glass. Now the question is, what is the composition of borax? Borax, a mineral of boron, with the composition Na2B4O5 OH 4 times 8H2O. You can also write the composition of borax as, okay, like this, Na2B4O7 10H2O, but it does not convey the actual composition. The actual composition of borax is Na2B4O5 OH 4 times 8H2O. Clear, no? We will be discussing a number of important questions from P block in our subsequent sessions. Thank you.